Hi, my name is Darren Doherty. Today, I will be exploring the relationship between diabetes rates and household income in West Virginia. I used R programming to analyze diabetes public health and income data, exploring how the two are related. I created some map visuals and a regression analysis, and I did all of this within R Studio. My sources of data are high quality government data sources, and they're all pretty recent, so I do feel rather good about them. I used geographic information from the tigris package in R, which itself uses US Census Bureau data. For my public health data, I utilized the CDC diabetes surveillance tool. And for income data, I used the most recent reports from the US Bureau of Labor Statistics. Now, my initial line of thinking, my initial hypothesis is that diabetes rates will be higher in areas of lower income. And I base this on factors such as availability of healthier food options, access to medical education, and these are both easier to access with higher income. My very first step was to prepare my geographic data. The Tigris package in R is a great source for this. All I simply had to do was filter a bit. I told it that I wanted to use its county level data, but only for counties within the state of West Virginia. What this did was provide geographic coordinates associated with a county name, and this allowed me later to create my map visuals as I combined it with diabetes and income information, which was also based on the county name. My next step was to actually go out and find the data. As I mentioned previously, I used US government official .gov websites and just downloaded the information as a CSV, which I later loaded into RStudio. I have a sample on the right of my diabetes information. The key items I want to draw your attention to are that I have a county name, and in this case, my diabetes information is under the percentage column, just shows the diabetes diagnosis percentage rate. And I did the same thing with my income information, which had the income levels associated with a county name. My third step was to join my data. And by this, I mean that I combined my diabetes public health data with the geographic data I prepared from the Tigris R package. Now, I mentioned several times how important it was to make sure that all of my data had a key that I could match to. In this case, it was the county name. And once I did that and joined it, you can see the snip here from my R Studio workspace. I joined the diabetes information, which is that same percentage column, with the information from Tigris to their common county name, and created this combined data frame that has both the map coordinates, you can't see them in the snippet, but they're there, and the diabetes rate. And I did the same thing for my income information in a separate data frame. With these combined sources of data, I was able to properly give R the instructions to associate, this diabetes rate with this West Virginia county, and then I plotted all of this on a map. Here we see the maps I created. On the left, I have the rates of diabetes diagnosis, and on the right, I have the median annual income levels by county. And on these maps, I included the geographic coordinates to kind of just highlight how the Tigris data associated the diabetes and income data with a specific county shape and area. So for example, if you think back to the last slide, the joined data frame that I had, it included a row for every county with a percentage diabetes rate and also a county name. So let's look at the diabetes map. If we look at Berkeley County, which is actually where I'm from, we can see that the data frame showed a diabetes rate somewhere between 10 and 11. And then it took the geographic information and it knew to associate it with the Berkeley County geographic coordinates. I have larger versions of these maps, which I will show on the next two slides. Here's the diabetes rate map. I'll leave it up for a few seconds in case you want to pause and examine it more closely. And here's my income level map, which I will also leave here. I'll just leave it up for a few seconds in case you want to pause it and take a closer look. My last step was to combine my income and my diabetes data to create a linear regression. And what that means is that I compared them to see if there was any kind of correlation or trend between the two. Each county is plotted at the intersection of its median income here on the x-axis and its diabetes diagnosis rate on the y-axis. And I calculated a trend line here in red and included a margin of error represented by the shaded area. This means that the red line signifies the most likely trend line, the most likely representation of that relationship between diabetes and income, but that actual trend line could fall anywhere within the shaded area. Remember, my initial hypothesis was that increasing household income would result in lower rates of diabetes diagnosis. So is that what actually happened? Let's take a closer look and break the components of this graph down a little bit more. My main finding, which I totally hate to admit, is that I was wrong. There is a moderately strong correlation between higher income and higher diabetes rates in West Virginia. And you can see this because as we move on the x-axis from left to right, which signifies an increase in income, the rate of diabetes also tends to increase. Now, the first question you may have is, how is that red line calculated? Why is it there and not some other place? Could I just go into Microsoft Paint and draw my own line and have it be just as accurate? Well, no. The red line, it represents a trend with the smallest total vertical distance between all the plotted points. So if you move the line, it would get further enough from some points to offset it getting closer to others. The exact location it's in right now kind of represents an equilibrium where it is as close as it can be to every point. And because that line is positive, meaning it slopes upward as we go from left to right, we can see that the relationship between income and diabetes is also positive. If my initial hypothesis was true, it would actually slope down, or in other words, diabetes rate diagnosis would decrease as income increases. Let's talk about the shaded area a little bit more, which in simplest terms, it represents a margin of error. This is where I'm saying anywhere in the shaded area, the actual trend line could exist. So why do I not know the actual trend line? That's because I'm only able to make an educated guess based on the data provided to me. The main issue here is that my data is incomplete, and even though it is of high quality, it's from respected US government sources, it's not possible, for the US Bureau of Labor Statistics to knock on every single door in West Virginia and account for every single person. If I was able to freeze time, go around and ask every single person in West Virginia their income, whether they were diagnosed with diabetes, and assuming they would actually provide that information, I would have perfect, complete knowledge of both these factors. And in this chart, there would be no shaded area. But that is impossible for most things in statistics, and if it is possible, it usually takes so long to gather that complete information that your data is obsolete by the time you compile it. Okay, back on track. We just established the red line and the shaded area are and why they are in the locations that they are. The red line is the most likely trend line based on the available data, but the true trend line could exist in theory anywhere in the shaded band. And one important thing to note is that the band does change width. The further you are from the red line, and the wider the band, the less likely that the actual trend line does exist there. And you can see in the middle of the line where there are more points of data, the band itself is actually more narrow because we are more certain. And on the edges, it's much wider. And that's because we have less points of data and we are less certain of where the actual trend line could exist here. So knowing that the shaded area is a margin of error, a better way to think of it might be as alternative trend lines. Less likely than the red line, but still possible. And the further they stray away from that red line, the less likely they are to be the true trend line. Let's look at this visually. So I can draw another trend line here in green, and that's within the shaded area. It is possible that that is a true trend line. Or it could be this one, or it could be this one. And in fact, I could keep drawing trend lines until I have thousands and thousands of them. And that's essentially what the shaded band represents. Long story short though, I would myself accept the red line and use it for my planning or for my analysis. Last thing is that with that demonstration of the shaded area and how it could just be a big mess of trend lines, one thing that I also discovered is that negative slope is possible. So I could draw a trend line like this, and you can see that it does barely slope downward. It is within the shaded area. Technically, this could exist, and this does represent diabetes diagnosis decreasing as income increases. However, one thing I do need to point out about that is that in order to make that line, I got to be at the very, very top of the shaded area on the left and the very, very bottom on the right here. That means that a situation like this is pretty much as unlikely as something could be, but still be technically within the realm of possibility. So out of all the possible lines you can draw, this red one represents the shortest average distance from all the points and the most likely trend line. All right, thank you for watching. If you made it to the end, hopefully you understand a bit more about statistics, public health in West Virginia, and if not, then maybe just lines and shaded areas. I can be reached at email, pretty simple, darren@darren.pro, or you can find me on LinkedIn with my URL just being my name, Darren Doherty. Thank you again for watching.